Okay, so we start. So this is our first class of mathematical economics by me. So Dr. Jugal sir is also facilitating one part of the quantitative methods in economics, and I will be facilitating the other part. So I'll be basically discussing to begin with on variables, constants, equations, then set the different operations and laws associated with a set. Okay, so I will be now sharing a screen with you. You just pay attention. Can everyone see the white screen?
Yes, sir.
Okay.
Yes, sir.
So this is class 1 of quantitative methods. So can you see the writing?
Yes, sir.
Okay, fine. Yes. So in quantitative methods, basically when we're talking about quantitative methods, so as I said in the orientation also, so mathematics or the mathematical methods is nothing but a language alternative to English or any spoken language, spoken or literary language that will be used to describe any economic model, to explore and analyze, critically analyze, okay, and to find solutions to the model. Okay. So basically, mathematics or mathematical methods is nothing but a language alternative to English or any spoken oblique literary language that will be used to describe any economic model, to explore and critically analyze and to find solutions to the model. So by now, I think you may have certain idea about an economic model. Okay. So first of all, an economic model is an abstraction from real world. Okay. So it's an abstraction from real world whereby we ignore the irrelevant details and focus on the important aspects of the phenomenon based on certain so economic model is an abstraction from reality whereby based on certain analytical assumptions. Okay. So based on certain analytical assumptions, we form an economic model, which is an abstraction from real world, and we ignore the irrelevant details and focus on the important aspects of the phenomenon based on certain analytical assumptions. So by nature, economic model is a theoretical construct and is not mathematical by default. Okay. So by nature, economic model is a theoretical construct and it is not mathematical by default. So you can also use language, okay, that is any spoken or literary language such as English to describe the economic model based on certain analytical assumptions. But when we use mathematical symbols, then equations and inequalities to describe the relationship between different economic variables of interest, then it becomes a mathematical economic model. Okay. So when we use mathematical symbols, equations, and inequalities to describe the relationship between different economic variables of interest, then it becomes a mathematical economic model. Okay, so by nature, economic model, by default, economic model is not mathematical. Only when we substitute the language of English or any spoken or literal language with that of the mathematical symbols and using equations and inequalities to describe the relationship, then it becomes a mathematical economic model. This is very, very important. Keep this thing in mind. Okay. So to start with mathematical economics or quantitative methods in economics, we'll have to begin with the certain concepts, that is variables, constants, and parameters. Okay, so to begin with, variable. Variable is something that can take on a defined set of values. So variable is something that can take on defined set of values. So if you have defined a set of values, a variable can take any values from that defined set. Okay, that means the value is not fixed and changes continuously. Or discretely. Okay. So when we denote a variable, we denote a variable by symbol. So we denote a variable by a symbol such as x, bit x, then y, z, etc. Okay. So what can be an example of variable in economics? Price of a good, cost of production, profit, okay, quantity of good produced, consumed, sold, bought. Okay. So these are the examples of variables in economics. Next, we come to the concept of constant. Something whose value remains fixed or unchanged. So constant is something whose value remains fixed or unchanged. So we usually denote constant by symbols such as x bar, y bar, z bar. So the bar over x, y, and z denote that the value is fixed or constant. So what can be an example of a constant variable? Constant. What can be an example of a constant? So it's a very relative concept to begin with. Okay. So when we are considering price of a good as such, it's a variable. Okay. Px, price of good x. It's a variable. But when we consider the price of a good in a budget constraint, that means this is your money income, M. So you will spend your entire money income on two goods. Let's say there are two goods, X and Y. So price of good X is Px multiplied by the of good X which you buy plus price of good Y that you buy, that is Y. Okay. So in this case, that is Px and Py bar, Px bar and Py bar. In this case, price Px and Py are fixed. Okay. Hence, they are given or constant in the model. So in a consumer model, which will, I don't know whether you have started with, when we are considering the budget constraint, which is given by this expression that is M, which is money income equal quantity of good X consumed, bought, multiplied by the price of good X, Px bought, plus quantity of good Y bought multiplied by the price of good Y, Py bought. So in this case, we assume that the price of X, that is Px, and the price of Y, that is Py, they are given and hence fixed in the given model. So this is an example of a constant. So other examples of constant, which you can get in macroeconomics is money supply. So money supply, let's say MS bar is given or fixed. Now, next we come to the concept of parameters. Okay, we come to the concept of parameters. So let's say when we write both a constant value, which is 7, along with a variable, we term this 7 as a coefficient of P, the variable. Okay. So 7P, so in this case, 7 is a constant, P is a variable, so 7 is nothing but the coefficient of P. But rather than writing just numerals, we can represent coefficients by symbols such as small a. Hence, we can write something as AP. So, we are generalizing this coefficient rather than putting it a particular value. So, this A can take any value. Okay. A can take any value, but once A is assigned a value, it remains fixed of the constant throughout the model in a given context. So A, which is a symbolic representation of a coefficient, it can take any value, but once it is assigned a value, it will remain fixed or constant throughout the model in a given context. So when such thing happens, then A, I have already said that A is a coefficient there, A is also termed as a parameter. So parameter are unique values of the coefficients which is taken by A in a given model under a given context and remains fixed throughout the model in that given context. Okay. Now next we come to something which will now help me to establish. So it is some sort of a wiring or a circuit, drawing of a circuit. If I use an analogy from physics, it is something like we are trying to now establish relationship between different economic variables or parameters or constants. So how we do that? The mechanism by which, or by the technique by which we establish relationship between different economic variables is through writing equations, inequalities, and identities. Okay. So inequalities, we will discuss this later in the course. So first we'll start our discussion with equations. So equations uses mathematical symbols and certain signs, that is plus, minus, division sign, multiplication sign, then equal to sign. So it uses basically these signs, then variables, coefficients, that is parameters, and numericals or numerals to establish relationship between different economic variables of interest. Okay. So basically, when you construct an equation, you use this symbol signs, that is plus, minus, division, multiplication, equal to sign, along with variables, that is the symbols which represent variables, coefficients, and numerals to establish relationship between different economic variables of interest. So equations can be of two types: identity equations, okay, behavioral equations, and conditional equations. Okay. So we'll start with identity equations. Okay. So
Sir, will you just
hello? Uses two alternate expressions that convey the same meaning using, so it uses this sign. Okay. So identity equation uses two alternate expressions that convey the same meaning. Okay. So let us think about profit. So profit, let's say we denote profit. There are two things. Profit, three things. Profit, we denote this by this symbol pi. Then revenue, that is the sales revenue, we represent this by R, and the cost of production, represent this by C. So we already have symbolized profit as pi, but we also know profit is also nothing but revenue minus cost, that is R minus C. That means these two signs, these two symbols, that is, or these two expressions, I should use the term expression. So these two expressions, that is pi and R minus C, they convey the same meaning. So how do we now write this identity equation? We will now write this identity equation as follows. That is pi, this symbol R minus C. So this is an example of identity equation. Or we can also write this as an identity in short. Okay. So they are alternate expressions R minus C as well as pi, that is conveying the same meaning, which is profit. Okay. Now, next we'll be defining this behavioral equation. So behavioral equation is an equation that denotes or describes the change in behavior of a given economic variable in response to changes in other economic variables. Okay. So a given behavioral equation is an equation that describes the change in behavior of a given economic variable in response to changes in other economic variables. So let us take an example. Cost of production. Cost of production C. So how the behavior of this cost of production variable C will change? It will change in response to what? It will change in response to the change in the output level. Okay. So let us consider the output level as a variable Q. Okay. So this will be nothing but it can be written as something like, let's say, A plus BQ, where A and B are parameters as explained. Okay, so cost of production C. So this is a behavioral equation, and how does it change? It changes in response to the change in the output level. Okay, so whenever the output level Q will change, because A and B are parameters, that means they are given in this model, that is a cost of production model. So whenever your Q will change, C will also change. It is not the other way around. So here Q will determine the behavior of the cost of production, not the other way around. That means cost of production is not determining the response or change in response of the output level, but it is the change in output level that is determining the change in behavior of the cost of production variable. Okay, so in this case, when the cost of production varies with respect to the change in the output level, so in this case there are two variables, C and Q are two variables. Okay, so C, since its value or behavior depends on the output level, so it is something known as the endogenous variable. What is endogenous variable? The variable whose value is determined within the model. So endogenous variable is that variable whose value is determined within the model. We can see very clearly that the value of C is determined by the Q. So whenever Q changes, C will change, not vice versa. Whereas Q is a exogenous variable. That is, its value is determined. Sorry, its value is not determined. Its value is given in the model. So we give particular values of Q, that is the output level, from outside the model, and based on those particular values of Q, we get the values of cost of production, which is an endogenous variable. Okay. Fine.
Yes, sir.
So now, this was a behavioral equation. Next, we have got conditional.
Sir, will you just show an example with
Pardon?
like will you just show an example with an exercise?
Will I show an example with?
X like sums like numbers.
Okay, I've already shown in cost. Okay, I'll show it. Okay, fine, I get your point. Just a minute. So let's say C is equal to, I've already said no, A. So A, let's say, stands for say 70 plus B stands for, let's say, 0.2 and Q. Okay, so just a minute, I have somebody at the door. Just bear with me for some time. Okay.
Okay, sir.
Very.
Okay. So C 0.2 Q. Now take on different values of Q. Q equal to 100. So substitute with different values of Q. Q equal to 100, then 200, then 300, then 400, then 500. What do you find? So what will be the corresponding value of C when Q is equal to 100? What is the corresponding value of C? Calculate it. When Q is equal to 100, what is C equal to?
90.
Okay.
90.
When Q is equal to 200, what is C equal to?
110. 110.
Q equal to 300.
130.
Q equal to 400.
150.
Q equal to 500. Q equal to 500. So what is C equal to?
And sir, 170.
Okay. So now are you getting an idea about the behavioral equation?
Yes, sir.
Okay. Now understand this thing. So behavioral equation I have given just a particular function from which was A plus BQ. Okay. Here we put the value of A equal to 70 and the value of B equal to 0.2. But I can also write this behavioral equation as follows. A plus BQ square. Okay. So Q remains unchanged. But will the value of C remain unchanged? So again, let us see that A is equal to 70, B is equal to 0.2. That means we can write this as 70 plus 0.2 Q square. But now the value of C will not be the same. So when Q is equal to 100, C is equal to how much? So Q square, 100 square means 2000. Sorry, 100 square means 10,000. So 0.2 into 10,000 is 2000. So 2070. When Q is equal to 200, so 200 square is how much? 40,000. So 0.2 into 40,000 is 8,000. So 8,000 plus 70 is how much? 8,070.
8070. 70.
So depending on the form of the behavioral equation, the response of the variable, so in this case the cost of production will change, or the behavior of the variable will change in response to the change in the other or given economic variables. So the structure of the behavioral equation will determine the extent of response or the type of behavioral response in response to change in other variables. So now we are into page 6. So now we come to something which is known as conditional equations. So conditional equations are those equations that express or describe the conditions, describe certain requirements that need to be satisfied in the. So conditional expressions are those expressions that express or describe certain requirements that need to be satisfied in the model. Let's say you are in the market. So in the market you have both demand for the goods, so quantity demanded, QD, quantity demanded, okay, and QS, quantity supplied, okay. Now in equilibrium, so now when the market is in equilibrium, what should happen? So what is the condition for the market to be in equilibrium? So for the condition for the market to be in equilibrium is that the quantity demanded should be equal to the quantity supplied. So this is the market equilibrium condition. Okay. So this is an example of a conditional equation. Fine. Now, in macroeconomics, we talk about money market equilibrium. So for money market to be in equilibrium, what do we require? Money market equilibrium condition. We require money demanded, that is MD should be equal to the money supplied, which is MS bar, exogenous. So MD should be equal to MS bar. Now there is one more condition, profit maximization condition. Profit maximization condition. So what does it mean? It means a marginal revenue. So marginal revenue should be equal to marginal cost. Okay. So based on the analytical assumptions made in the model, for the model to hold true, okay, based on the analytical model, assumptions in the model, for the model to hold true, there are certain requirements need to be satisfied, and the equations that express or describe those requirements that need to be satisfied so as to have the model to be true based on the analytical assumptions are known as conditional equations. Okay, fine. So now we move to something which is known as the number system. Okay, so I get to one new fresh page. Real number system. So in economics, when we are giving values to variables, constant parameters or coefficients, we use some numerals or numerical values. So let's say 1, 2, 3, 4, 5, 6. So these are what? These are positive numbers. Okay, positive numbers. Then -7, -8, -9, -11, -12. What are these? Negative numbers. In addition to this, we also use another number which is 0. So neither negative nor positive. Okay. So it is neither negative nor positive. It is just 0. So it's a unique thing. So when we include all these negative number, positive number, and 0, we get what is known as integers. Okay. Fine, to begin with, integers. Now, when we take ratio of integers, so let's say we take, so let's say P and Q are two integers such that Q is not equal to 0. Okay. So now when this ratio of two integers, so ratio of two integers, of these two integers, P and Q, in this form, P by Q, where Q is not equal to 0, we get what is something known as fractions. Okay. Fractions. So these fractions can be equal to an integer, or it can be between two integers. Okay. So any number of this form P by Q, where Q doesn't belong to 0, are known as rational numbers. Okay. So they are known as rational numbers. So rational numbers includes integers and fractions. Okay. So rational numbers are nothing but integers plus fractions. So integers are special cases of fractions. Okay. So when it is in the full form, that is 1, 2, 3 as such. Now there are other types of numbers. What are those numbers? So the numbers which are of this form, let's say pi, root over 2, okay, root over 7. So wherever you don't, whenever you are getting the numbers on the right side of the decimal, they are never ending and recurring. Okay, they are never, so not recurring, they are non-recurring. So you get numbers on the right. So when you simplify these expressions, that is pi, root over 2, root over 7, you get the numbers on the right side of the decimal which are non-recurring. So in such a case, this type of numbers are known as, which cannot be simplified further, this type of numbers are known as irrational numbers. Okay, irrational numbers. So when you consider both these numbers, that is rational plus irrational numbers, you get something which is known as real numbers. So fractions means which are not whole numbers like 0, 1, 2, 3 and such. So they lie between two integers. Okay. So fractions lie between two integers. Okay. Integer is also special case of fraction. So when we include both these fractions and integers, we get what? We get rational numbers. And between two rational numbers, there is an irrational number which cannot be simplified further. So rational number is a special case of an irrational number, which is, rational numbers are numbers which can be simplified, but irrational numbers are numbers which cannot be simplified further. So we get, including them, rational and irrational, we get real numbers. Okay. So in economics, whenever we'll be dealing with numbers, we'll be dealing with real numbers. Usually, in most of the cases, we'll be dealing with real numbers. Okay. So that's what I have for today for this first class with you. So we will be following this book. I am following this book by Chiang and Watright. I think I don't know whether Jugal sir has shared this book with you. So I'll be sharing this book with you in your Google Classroom. So what you can do,
Sir, he has given.
what you can do is as follows.
He has given. Sir.
I am in the WhatsApp group. Okay. So just send your email IDs. Send your email IDs. I don't have your email ID, so just send your email ID. So I'll be mailing the link. So the class which I have got, I will be uploading this on YouTube. I'll be mailing the link of this YouTube YouTube for this class, which you can view later. Okay, and along and other materials that I can send you from time to time. So any questions? Any doubt?
No, sir.
No, sir.
Okay. So thank you and have a nice day.
Thank
Thank
you,
you,
sir.
sir.
Thank you.
Thank you.